Hey, 5th grade, how's it going? Happy Friday, August 21st, 2020. Today, what students are going to be doing is investigating how to use the protractor, classify triangles and quadrilaterals, and explore properties of angles of a parallelogram. Last time, on Tuesday, what we were able to do was learn how to classify properties of angles and triangles. If you didn't get a chance to look at that video, the link is on the screen and it's also on the YouTube channel. I'll also put a link in the notes section on the bottom, so check that video out. Today, like I said, we're going to be looking at how to use a protractor. Now, all these links are going to be in the notes below, just in case you missed something in the video. This tool is very important when we're looking at angle measurements, okay? If we're going to look at, for example, the angle measurement of MLN, which is on the screen right here, you can see MLN, which is on there on the screen, we're going to use a tool called the protractor. In Spanish, it's called the transportador. This little tool gives us an angle measurement between 0 and 180, which is the exact same measurement of a line segment. If we move our protractor over to the middle of the segment so that it's in line with point L, we can see that this protractor will give us an exact angle measurement of the angle, right? Inside of this line segment, you can see that the protractor shows us 60 degrees. We can go from 0 and count up 0, 10, 20, 30, 40, 50, 60. So that angle measurement is the exact degree measurement of MLN. We'll do more practice with that a little bit later. We can also recognize that these angle measurements can be also found inside of some triangles, right? We're going to be doing some exercises with triangles, but before we do that, I want to make you understand that the angle measurements inside of a quadrilateral can also be equal to 180 degrees. For example, if I move these vertices of B right here inside of my quadrilateral, you can see that the angle measurement B is also changing, right? It goes up and down. If I add the angle measurement of A and B, it's going to equal 180 degrees, okay? If I add the angle measurements of B and C, it's also going to equal 180 degrees. You see these mini protractors on the bottom right there. Same goes with C and D or D and A, okay? Those are complementary angles. So in other words, if I add up 70.51 plus 108.49, it's going to give me the angle measurement 180 right here, right down here on the bottom. Or if I add up, for example, 72.69, which is the angle measurement of C, plus 107.31, it's also going to give me 180. So if you want to check this link out, this will be in the video notes below. We were able to practice that to understand angle measurements just a little bit better. Okay? Let's take a look at classifying triangles now. Now I think that it's important, boys and girls, that we understand that when you classify a triangle, you can classify it in two different ways. Last time we learned about the different angle measurements, and angles can be classified by right angle measurements, acute angle measurements, or obtuse. A right angle is 90 degrees. In other words, like a square. An acute angle is less than 90 degrees. So it could be 85 degrees or 60 degrees, like in our first example. And an obtuse angle is larger than 90 degrees. So it could be maybe 100 degrees or 130 degrees. Now, we can also classify triangles by their side measurements, okay? Sides of triangles, even though there are 3 sides, can be either long or short, depending on the angle measurements, right? If the lengths of the triangles are all the same, we have an equilateral triangle. In other words, all sides are the same length. Whereas an isosceles triangle has at least two sides that are the same length. Here you see the example in green. And then the last one is a scalene triangle, which has all the sides with different lengths. What we're going to do is play this game so we can recognize the different types of triangles. Let's try first with our angles. Let's try to find a triangle that is considered obtuse, or I'm sorry, an angle that's considered obtuse. Remember, that's larger than 90 degrees. Here's one, here's another. Oh, apparently, okay, now we're going to right triangle. Acute angle would be smaller than 90 degrees. There's one. Obtuse is larger than 90 degrees. Acute is smaller than 90 degrees. Okay, so you kind of understand the point of that. We can also classify these triangles by their sides. So let me click on the same link, and we're going to practice classifying by their side measurements, just like we did before. Okay, while I wait for that to load, I'm going to show you one more activity that we could do by classifying quadrilaterals. Okay, we did this activity in class. We got 6 out of 15 correct. The question says, which quadrilateral always has 4 right angles? Well, this first one doesn't have right angles. Neither does the third one, and neither does the fourth one. So I think it's a rectangle. Let's submit that to see if that's correct. Not sure if my internet's working right now. Okay, we'll come back to that to see if that answer was correct. Really not sure. What we're going to do now is we're going to classify triangles by their side measurements. Okay? So let's see if we can understand what types of triangles would be considered equilateral triangles. Remember, equilateral has all the sides that are the same. This purple one was equilateral. Scalene, remember, was all the sides are different measurements. So this one is isosceles. I'm not going to click on that one. Oh, there's a scalene. Okay, here's my isosceles triangle. And my scalene again, here we go, that smaller one. Equilateral is all the same. Isosceles has two sides that are the same. Equilateral is all the same. Isosceles, scalene, equilateral. All right, we got 100%. Nice job. Okay, it looks like this. Oh, there was an error. That's fine. We'll try it. Try it again. There we go. Gotta love technology. Let's try another question. It says, drag the quadrilaterals with right angles into the box. Now, as we remembered last time from the previous exercise, that right angles are 90 degrees. So this one has 90-degree angles, and this one has 90-degree angles, both the square and the rectangle. Unfortunately, these two do not have right angles, okay? These rhombuses. So let's submit and see if we're correct. We got it. Good. Let's try another question. Question says a square has 4 equal sides and 4 right angles. Is that true or false? Well, that's true. For sure. Each one of them are the same, and the angles are also the same measurement. All right, good. So if you want to check out this link, you can do this activity a little bit more. Let's do one more question. How many pairs of parallel sides does a rhombus have? Well, a rhombus, like we did last time, has 2 pairs of parallel sides. Okay, it doesn't have 4 parallel sides, it has 2 pairs of parallel sides. If we wanted to draw a rhombus out, we could do that. That music. This right here is a rhombus. Okay, so it has 1 pair right here and 1, nope, that's not a rhombus, sorry. This is a rhombus. 1 pair right here and 1 pair right here. Okay, this would be considered a different type of quadrilateral. It says identify the quadrilateral that is a parallelogram. Well, this one's parallelogram. This one, and this one are not parallelograms because they don't have two pairs of parallel sides. So we're going to click on the first one. The robot barks, apparently. Great. All right. I think that's it for this quiz. You can check this out a little bit later on. There's also this game right here where you have to drag each triangle in the correct basket before time runs out. So here we have acute. Ooh, where are my acute triangles? Here's one. A right triangle. Oh, is that one? Right there. Obtuse. I see an obtuse triangle right there. Okay. Another right triangle. Where is one? Let's see. I can't find one. An acute triangle. Let's find one right here. Oops. Right there. Okay. Another obtuse triangle. Okay. A right triangle. Let's see. Oh, apparently that's not a right triangle. I need to find a right triangle. Where is it? It's kind of hard when you can't see it and it's going so fast. Is this one? Here we go. Okay. Let's see. An acute triangle. An obtuse triangle. All right, so you get the understanding, right? I'm going to put this link in the notes so you guys can play this at home if you want, all right? So today what we were able to do, boys and girls, is understand a little bit more about using a protractor, classifying triangles and quadrilaterals, as well as the properties of both quadrilaterals and and triangles. So we will continue to practice this a little bit more later on. Thanks for coming to class and for participating.